So for this video, we'll be learning how to make use of the half-angle identities. So for the half-angle identities, so for sine of a over 2, it's plus or minus the square root of 1 minus cosine of a all over 2. For cosine of a over 2, it's plus or minus the square root of 1 plus cosine of a all over 2. You will notice that for tangent, there are three equations, but the other two were basically derived by rationalizing either the numerator or the denominator of the equation. So in here, tangent of a over 2 is plus or minus the square root of 1 minus cosine a all over 1 plus cosine of a. So you'll notice that there are plus or minus symbols in here. Do take note that the signs follow the signs of the trigonometric functions where the angle, the half angle, a over 2, lies. So just to recall, in the first quadrant, all trig functions are positive. For the second quadrant, it's sine and cosecant. For the third quadrant, it's tangent and cotangent that are positive. And for the fourth quadrant, cosine and secant will be positive. So let's try. Find the exact value of cosine of pi over 8 and sine of pi over 8. So without calculators, how do we do this? So basically, cosine of pi over 8, we can say that this one is basically cosine of pi over 4 all over 2. So what's cosine of half of pi over 4? I can say, first question, pi over 8, it's an acute angle. It's in the first quadrant. So that means we will be using the positive square root of 1 plus cosine of pi over 4 all over 2. Thing is, you're using pi over 4. Let's draw the 1 square root of 2 or the 45 triangle. So in this case, this is 1 plus square root of 2 all over 2 all over 2. So let's rationalize the top. That's 2 plus square root of 2 all over it's this one. This would be the answer. What about for sine? Sine of pi over 8. We can say that this is sine of pi over 4 all over 2. So similar, since pi over 8 is in the first quadrant, sine would be positive. So 1 minus cosine of pi over 4 all over 2. So this one would be 1 minus square root of 2 over 2 all over 2. And then there's a big square root outside. This would be 2 minus square root of 2 all over 2. And then over 2. So this one would then be 2 minus the square root of 2. And then that's all in square root divided by 2. For tangent of 112.5, we can say that tangent 112.5 degrees is basically tangent of 225 divided by 2. So we know that 112.5 is greater than 90 degrees. So this one is in the second quadrant. And tangent in the second quadrant is negative. So please do take note of that. So tangent, if you want, you can use the first formula, the second, or the third. But with me, I would prefer either the second or the third formula. Why? Because the first formula contains radicals, and sometimes, radicals can be tricky. So for me, I would say sine of 225 all over 1 plus cosine of 225. Remember, the answer should be negative. Let's check. So in here, it says 225. Let's try to draw where 225 is. 225 is in the third quadrant. That is actually 45 degrees in the third quadrant. So let's draw that. That's 1 square root of 2, but then it's negative and negative in the third quadrant. So with that, let's try answering. Sine is opposite over hypotenuse, so negative 1 over square root of 2 all over 1. Cosine is adjacent over hypotenuse, so negative 1 over square root of 2 as well. If you want, we can rationalize it immediately. This one would then be 2 minus square root of 2 all over 2. So here, you can actually cancel the 2 and the 2. And then let's try rationalizing or simplifying this. You're actually left with negative square root of 2 all over 2 minus square root of 2. So how do we simplify this? By rationalizing the denominator. So let's multiply this by the conjugate. You'll have negative 2 square root of 2 minus 2 all over. This is 4 minus 2. So if you can factor this out, you'll end up with square root of 2 plus 1 all over 2. Therefore, your answer is negative square root of 2 plus 1. So as I said earlier, here, reminder that the answer would be negative, so you're correct. So let's go to the next. It says here, given that cotangent x is 5 and that x is between 180 and 270, so we know that's in the third quadrant, you're asked to find sine of x over 2. So let's first draw the angle. The angle should be in the third quadrant. So this is your x. It's cotangent. So opposite over adjacent, that becomes adjacent over opposite. So 25 and 1 is 26. This one would be the square root of 26. That's negative. That's negative. So let us evaluate sine of x over 2. We know that x is found in the third quadrant, but then sine in the second or first quadrant would be positive. So that means if an angle is in the third quadrant, let's just say it's close to 270. So half of that, half of 270 is already 135. You know that it ends in the second quadrant. And then if it's closer to 180, let's just say 182, it would be 91 degrees. So whatever happens, half of those angles will end up in the second quadrant where sine is positive. So now we know that we should be using the positive for the square root. 1 minus cosine of x all over 2. So let's solve this. The square root of 1 minus cosine of x adjacent over hypotenuse. So let's just make this plus 5 square root of 26 all over 26. But then all of this is over 2. So let's fix the top first. It's going to be 26 plus 5 square root of 26 all over 26 times 2 is 52. So let's try to remove what we can remove. Square root of 52 is 2 square root of 13. So in here, we can already remove first. So 1 over 2. This is going to be 26 plus 5 square root of 26 over 13. In order to rationalize this, we need to multiply everything by the square root of 13 over square root of 13. So 1 half square root of 26 square root of 13 plus 5 times 13 is 65. And then you're left with the square root of 2. And then the bottom, that's going to be 13 squared. Or what I can do here is the square root of 26 square root of 13 plus 65 square root of 2 all over. There's 13 squared and 2, so that's over 26. It's going to be positive. Lastly, if cosecant is negative and theta is in quadrant 4, then theta over 2 is in quadrant number 2, determine sine, cosine, and tangent. So you know that in here, cosecant was given to be in quadrant number 4 already. So this is your theta. Cosecant is hypotenuse over opposite. Since it's going down, it's negative. So 61 squared minus 11 squared, you're going to have 36. That's going to be 60. So it's a 60, 61, 11 triangle. In here, it already says that theta over 2 is in quadrant number 2. That means in quadrant number 2, this would be negative, this would be negative, this would be positive. Therefore, sine of theta over 2 is simply the positive square root of 1 minus cosine theta all over 2. Let's evaluate this. Positive 1 minus cosine of this one, adjacent over hypotenuse. So 60 over 61 all over 2. So simplifying this would be 1 minus 60 over 61 is 1 over 61. So this one would then be 1 over 61 all over 2. Simply 1 over 1 to 2 inside the square root. Or if you want, you can make this square root of 1 to 2 over 1 to 2. So it's positive for sine. Now let's try cosine. Cosine theta over 2, we will use the negative sign. Why negative? Again, because theta over 2 is in the second quadrant and cosine would be negative there. So 1 plus cosine theta all over 2. So it's going to be negative 1 plus 60 over 61 all over 2, 121 over 61 all over 2, 121 over 122. So 121 is 11, square root of 122 all over 122. And then let's not forget the negative sign there. So the first is positive, the second is negative, and then the last for tangent of theta over 2, I could use the sine theta, 1 plus cosine theta. So let's evaluate this. For sine, opposite over hypotenuse, so that's negative 11 over 61. For cosine, that is positive 60 over 61. So let's evaluate this. 61, 11. Here, it's going to be 121 over 61. The 61 cancels out. You're going to be left with negative 11 over 121 or negative 1 over 11. You'll notice that this one is negative because tangent in the second quadrant is negative. So that's it. I hope you understand the lesson.